This function kxy has a sinusoidal curve on the y direction, which means if this is x, that's y, then as you go in the y direction, it's bumpy, right? So in other words, there are points where it's maximum and then some points that are minimum and so on and so on. And then also it has some kind of curve in the x direction, some kind of cubic curve. So you can kind of expect that this function will have several critical points, and the answer is yes. There has like infinitely many critical points. But here, instead of asking you to find those infinitely many critical points, it found one for you. So 2, 1 happens to be a critical point. You can check by taking the gradient and showing that the gradient is indeed 0 at 2, 0. But now what it's asking you to do is to figure out whether that 2, 0 is a saddle point or a relative maximum, a local maximum or local minimum. Right? That's the idea. So let's try to do exactly that. So second derivative test means you calculate the Hessian and use that to figure out if it's a saddle or not, and stuff like that, okay? So first, what's the gradient of k? If you differentiate this by x, that's 3x squared minus 6x plus 5. And then sine y, that's what you get for the derivative with respect to x. If you differentiate this by y, this time you're just differentiating sine y, so the x part doesn't change. And then you have cosine y. Okay, in fact, if you compute gradient of k at 2, 0, that means you plug in x as 2 and then y as 0. Now sine 0 is indeed 0. Okay, so if you plug in 2, I don't know what, it's some value times 0. And then if you plug in 2 here, that's 8 minus 12 plus 10 minus 6 times cosine 0 is 1. And indeed, that's 18 minus 18, so it does give you 0. So this does give you 0, 0. So you can verify that indeed 2, 0 is a critical point. Okay, now since it's a critical point, let's calculate the Hessian. So Hessian of k is this matrix of second derivatives, right? So you have to differentiate twice in x, or x and then y, or y and then x, and then y. And it's always the case that these two are the same, so you don't have to calculate this separately. Just calculate this and put it over here. Okay, so what is kxx? Well, this is kx. This one is k differentiated by x once. So if you differentiate twice, that's going to be 6x minus 6 sine y. Kxy would be taking this one and differentiating by y. So that's 3x squared minus 6x plus 5 times cosine y. And then kyy means you differentiate with respect to y twice, so you're just differentiating this by y twice. Cosine y differentiates to negative sign, so that's what you get, okay? So we could use this to build that one, but since we just need the Hessian at this point, 2 comma 0, let's do that. Okay, so let's compute hk 2 comma 0. Okay. So first of all, when you plug in 0 into sine, it's always 0. So these are zeros. You get that? Yeah, sine 0 is 0. So whenever you have y as 0, these are going to be 0. The only thing that's non-zero is this guy here. Let's see, if you plug in 0 for cosine, cosine 0 is 1. How about this? 12 minus 12 is 0, so it's 5. So it's going to give you 5 here, and then 5 here, and then 0 comma 0. It's a determinant. Okay, what's the determinant? Yeah, it's 80 minus BC, right? So 0 times 0 is 0. 5 minus 5 times 5 is 25, so negative 25. Okay. If you have Hessian negative, what does that mean? That means there's one direction where it's a smiley face, but there's another direction which is a frowning face. Okay, what kind of point is that? Saddle.